Another problem, so close to using the difference of two squares. We have a difference, we have a square number, except our a is not a square number. So we can't apply the difference of two squares because we're not going to have the same number that's going to multiply to give us 3. The only two numbers that multiply to give us 3 is 3 or 1. So therefore, we can't apply the difference of two squares. However, we can apply the square root method. So I'm going to set this equal to 0. So I have 3x squared minus 25. And the reason why I can apply the square root method is because it's in this format. However, now I'm just going to use my inverse operation. So I'm going to add 25 to both sides. So now I have 25 equals 3x squared. Then I'll divide by 3. Therefore, I have 25 over 3 equals x squared. Now I need to take the square root of both sides. Now, when I take the square root of both sides, you see that I can take the square root of 25, but I cannot take the square root of 3. So therefore, this is going to be plus or minus 5 over the square root of 3 equals x. All right, and then what we learn about square roots is we always want to make sure that we can rationalize the denominators to simplify the answer, because we don't want to divide by an irrational number. So therefore, my final answer is going to equal plus or minus 5 square root of 3 over 3. And you got to make sure whenever we introduce the square root, we need to make sure we include plus or minus. So there you go, ladies and gentlemen. That is how you solve the equation using the square root method. Thanks.